What is up, most distinguished patrons of this channel? Today we are going to get away from doing beads on plate, spot welds, letters that we did in the previous video, and we're going to focus on actually welding joints with TIG. So let's get into it. So I get it, guys. You've been watching these videos. I've done 5, 6 of them so far on how to TIG weld, and virtually none of them had me actually welding real joints like lap welds and fillet welds. And there's a very good reason for that. And that is that you have to master running simple short beads, even if they're an inch or two long, before you go and waste a ton of material welding stuff when you don't understand the basics. Now, look, you can do anything you want. I'm not stopping you, and I'm not telling you that you have to do what I tell you to. I'm just explaining that you have to master the simplest part of TIG welding, which is running a bead on a flat plate, to get the most out of actually welding joints. Because, like it or not, I hate to tell you, at some point you have to master this. You might master doing lap welds or fillet welds, but you're going to spend more time doing things wrong trying that than you are just getting the BS stuff you don't want to do out of the way first. And my father had a saying on that. He says, what you least want to do is probably what you need to do the most. And with TIG welding, that is mastering the simplest thing. A bead that's straight, equal width, equal height on flat plate, and doing hundreds of them. Nobody wants to do it, but everyone needs to. Okay? So now that we're all on the same page regarding that, I think it's safe to say that if you've watched the previous videos in this series, you have a great idea of the basics of what you should be doing. Now let's talk about actually taking that and becoming a functional TIG welder by actually welding things together, because we have yet to do that. So what we're going to focus on today is doing a simple butt weld, where we're going to take coupons, put them together, and weld them. We'll be starting with fusion welds at first, and I'll discuss that. And then we will go to adding filler, and we'll also weld them with a little bit of a gap so you get used to that. Because guess what? In the real world, you're not always going to have a perfectly tight fit, and sometimes that's even undesirable. So you have to learn how to weld with a gap. So to start things off, let's do a little bit of book learning, and then we'll get to actually welding. So depicted in front of us are basically the same butt weld. This we're looking at a side shot, this we're looking at it head on. I'm going to focus on teaching you how to do butt welds first because, well, when I was in school, that's what they taught us, because the success rate's fairly high. It doesn't take that long of practice when you can already run beads on plate to be able to do a pretty good job with butt welds. Everything else tends to be a little bit harder, and hey, you got to start somewhere, right? But speaking of butt welds, there's a couple things that you want to concern yourself with. Now, in this video, I'm going to be using roughly 1/8 inch material, or 3.2 millimeter. You can use thinner or thicker. If you're on more of a budget, you'd probably want to use thinner because it's cheaper and you can get more practice. Keep in mind, though, the thinner you go, the harder it is to do a butt weld without blowing a hole. So in some sense, if you can master really thin material fast, or in first, we'll say, you'll probably be a better TIG welder quicker, but at the same time, you're going to be more frustrated. So depending on how much you can handle for frustration should dictate how thin you go to start with. But my recommendation is somewhere between 2 and 4 mil, or I don't know, 1/8 or a little bit under that, 1/16 to an 1/8. Don't try and use sheet metal like 20 gauge or something. You're just going to be frustrated. So anyways, with the TIG process, one of the things you got to understand is that it is a very low penetration process. It universally achieves root fusion, where like in a fillet weld, it's able to fuse where they meet reliably, but it's not going to be knocking way in on thicker plate. It just doesn't penetrate that much, and that's because it's more or less just a heat source. It's not like spray arc or stick where the metal is being driven into the joint. It's basically just heat. So however much heat you put in determines how much penetration you have. Well, beyond a certain point, you're just not going to have much penetration. And I'll be doing a couple demonstrations with actual welds to show you that. But what you need to understand is when you're learning this at first, don't have a gap between the plates, especially if it's thin material. And you're going to want to tackle this fusion welding at first, aka no filler, because once you can reliably fusion weld two things together with no gap, then you can start adding filler, and then once you get good with filler, you can then start welding with a gap. Now, speaking of that, when you butt weld two pieces up and then you weld it with no filler, more or less what's going to happen is the weld will dish, and let me show you this. So here is, you're going to produce, here's the two plates where they meet, you're going to tend to produce what's known as underfill or undercut. Because you're not adding filler, it's going to melt the edge a little bit down, and it's going to join the material more or less like here. This is going to be your weld per se. And a lot of people have asked me, well, is fusion welding as strong as using filler? The answer is typically not, simply because you don't have any reinforcement. If you were to weld these two plates and this is what your weld actually looked like because you didn't add filler, is that strong, or would this be strong if you added filler to it? Obviously this, because more weld is there, more of the plate is actually joined. So when you do fusion welds, you want to be careful because your actual weld is going to be pretty thin. On sheet metal, it works great because look at how thin the material is. It's thinner than this line here. So you will have a pretty strong weld, but on something as thick as this or this, which this is ridiculous, it's like 1 inch, but this is like 1/2 inch. No, you're not going to have a very strong weld just doing a fusion weld because there's no depth of weld. There's no actual like joint between those. So anyways, back to what I was talking about. On your typical 3mm or so or 1/8 inch material, you're going to want to do a fillered weld. You want to add filler. You don't want to just fusion weld them. There are some exceptions to that. If you are welding an outside corner joint, you can oftentimes get away without using filler. However, in the video I do on outside corner joints, you're going to find that you got to be very careful with that because you can more or less just end up melting this off, and the joint here is half or less of the thickness of these plates. So again, I'm going to give you a lot to think of regarding fusion welds in the future. You got to be careful when you do that. So universally, you're probably better off using filler. Now, in case you're wondering, you could technically do a weld that is a fusion weld, and then once everything's joined, go back and weld over the top of it with actual metal with filler. That's a possibility as well, and those are all things that will be discussed in this video series in multiple ways in the future, and possibly even further in this video. Now again, the setup should be take your two plates, no gap, and we're going to run, because this is roughly 3.2 or 1/8 inch material, we're going to run at about 120 amps. And that should be the ballpark of what you're looking at. So what I'm going to do is get set up, and we're going to start welding. So we're going to watch this in real time, one time with me commenting and one without. Everything is fusing together nicely here. However, my travel speed is a bit on the high side, and you can tell that because of how narrow that fusion weld is. And that's something you got to be careful about. You can also tell by the heat affected zone coloring how narrow it is and close to the weld, that it was run a little bit too fast. Now let's just look at it without commenting. Based on what we see here, One of the telltale signs that I was consistent as a welder is the fact that the heat affected zone lines that turn red and blue and purple are very consistent. Now, no, they're not a straight line, and my travel speed was a little bit inconsistent, but for the most part, they look very good. If you see very inconsistent heat affected zone lines, that's telling you that your travel speed, your arc gap, all of that is just not consistent. You want to see more or less a fairly straight line. That would be ideal. Now I'll put up another picture now that we can look at. And one of the things that happens when you do fusion welds with no filler is plates tend to warp a bit. In that picture, you can see that the plates are more or less a V. That becomes exaggerated when you don't add filler. When you add filler, oftentimes it'll be a little bit flatter. The second thing that you can see is more or less this whole weld is underfilled. It is below the surface of the plates. Now that is to be expected because we didn't add additional filler metal for reinforcement. And that is why, like, doing something like 1/8 inch material as a fusion weld is kind of not really in your best interest on a butt weld like this, because there simply isn't much attaching to plates, or these two plates together. Case in point, the back of it. Because I didn't run a gap and I wasn't running anywhere near enough amperage, there is zero penetration through these plates. There's a completely original edge there, and that is to be expected. And that is why adding filler and then running a slight gap will increase penetration, because the TIG process has basically no penetration whatsoever. I mean, very little. And by running a gap and adding filler, we will be able to achieve in one pass more or less a weld that's approximately the thickness of this material, so that we have a strong joint. What we have here is not a strong joint, and I will prove it by cutting this in half, etching it, and let's look at what we have. So I did a cut and etch on this, and the etch is almost impossible to see, and that's because we didn't add any filler metal of a different alloy, so more or less the etch doesn't really show the weld nugget per se. But what I ended up doing is bending the plate just enough to show the depth of fusion, and let's put a picture up and look at that right now. Now, as you can see, this fusion weld, despite on surface value looking like a decent weld, basically has no penetration whatsoever. This is only 3.2 millimeter, aka 1/8 inch plate, and we're not even, I'd say, about a quarter of the way through the plate at 120 amps. So that's virtually no penetration. Now we're going to do some arc footage where I add filler, and then we're going to cut and etch it and look at that and talk about that. So for this weld, I'm just starting the arc. I'm waiting for the puddle to get about 3 electrode widths, so 3 times as wide as a filler rod is. And then I'm just slowly pushing filler in. Now this, I'm more or less tapping the filler rod. I'm not pushing that much in. If there was a gap, or I was running more amperage, or the puddle was wider because I was moving slower, I would need to push in more rod. I personally tend to retract the rod enough to where I can see where the two pieces of metal are joined. That way I know for a 100% fact that I'm fusing the root and getting some penetration. The main things that you need to focus on is just keeping a consistent arc gap and a consistent travel speed and a consistent filler metal addition. Now that I'm almost done with this, I'll play it one more time without any commenting. Oh, and I dipped it there too. So here we have the weld I just ran, and I ran it with filler, same 120 amps. Now there's a couple key differences that I want you to pay attention to. Here is our weld that was just a fusion weld, and if you notice, the heat affected zone lines are both wider and more prominent. The bead itself is also wider. That is because while I was adding filler, I had to wait longer at 120 amps to make sure that everything was hot enough that the filler melted, that the weld wetted out, etc. Well, by doing that, my travel speed forward slowed down, therefore my heat input per second, we'll call it per second, increased, therefore we have much more heat input and wider heat affected zone lines. On clean material, TIG will always tell you what your heat input is. This is clearly not very much heat input, this is clearly a lot more. The heat colors don't lie to you. Now we had differing results here. As you can see, we actually have some melt through on this 1/8 inch material versus this same material has 0. And there's a very good reason for that. TIG achieves fusion via amperage and travel speed. It's very common to simply weld too fast, especially with fusion welds, and the end result is a severe lack of fusion, or basically penetration and fusion. By slowing down, which I had to do via adding filler, I was able to actually achieve more fusion and a better result. Now, you can do the same thing with a fusion weld if you simply slow down. I'll put up some arc footage right now of slowing down with a fusion weld over this, and let's look at it. So to start things off, we're going to run this weld fairly slow, and don't worry, I'll do a direct video comparison between this weld and the one earlier where I basically ran too fast. But the puddle here is getting pretty wide. It's about 4 electrode diameters, so I'm using 1/16 filler, so 1.6 millimeter filler. It's somewhere around 1/4 inch wide, and this is perfectly acceptable. Now, had I gone any slower than this, I would have started to get melt through where the weld would have just sagged out the bottom. And keep in mind that I have no weld reinforcement because this is just a fusion weld, so it's a literal concave weld the whole length. Now let's look at how slow this actually is. The top weld is moving slow, same 120 amps. The bottom weld is the first weld we saw arc footage of, and both of these are real time and the same exact length plates. And you'll be able to see how wide that fusion line is, the difference of that, and this is exactly why you have to be careful when doing fusion welds or any weld with TIG that you don't move too fast with too low of amperage, because we'll see the actual results of what that top weld looks like. And you can see we're not even halfway done yet, and it's still going, so be very careful running too fast without enough amperage. Well, let's look at the results of this once this is done. So here is that fusion weld that you just saw the arc footage of, and you can tell just by the way this looks at how high the heat input was because of my slow travel speed. When you compare it to this other fusion weld, it is a night and day difference. Therefore, the results are also night and day different. And I'll put pictures comparing these two up right now and talk about it. So what we're dealing with is we were able to almost fully weld 1/8 inch material via a fusion weld and produced a very strong weld without filler, simply by slowing down. And this is one of the biggest things that is a detriment with TIG welding, is that people tend to move too fast and not enough amperage. When you combine those two things, you get results like you see in this video, where one weld, even though visually it doesn't look that bad, it is very weak. And the other weld, which visually looks a little bit hot, but it's okay, it performs far better. And that is direct result of the correct travel speed, the correct amperage, and the correct tungsten arc gap. I personally find it easier to achieve really good full fusion on, say, 1/8 inch 3.2 millimeter plates when I add filler. The reason is the filler forces you to slow down. It's very easy to run too fast when you're not running filler, as I proved in this video so far. Now, going back to the whole fusion versus filler weld argument, I personally do not make a habit out of doing fusion welds on anything except for very thin material, typically on outside corner joints, because it works well in that case. When you don't add filler, the risk is well, for one, you might move too fast and lose penetration. That's not good. Two, arguably, the alloy of the filler rod being added would likely make the weld stronger than the base material, and that can be a good thing in a lot of cases. So I see that as a detriment by trying to use the plate itself as filler, especially if you happen to weld something like tool steel or any number of higher strength alloys. If you do not use filler and just try and melt the base material onto itself or use it as filler, you will suffer from cracks of that weld, guaranteed. So filler is generally better than no filler, especially on higher strength alloys. But realistically, what I find is rarely is something I'm welding the fit up so good that I don't run into an issue where I pop a hole somewhere. And if you just try and fusion weld everything and then you get a hole, well, you can't use the filler rod to cool the puddle in order to control that and keep welding. You now have to go back over that with filler rod to fill it, because I'll tell you what, if you have a poor fit up, there is zero hope of a fusion weld somehow bridging a gap. It doesn't work like that, and the thinner the material, the worse off it is. Now, with that said, let's look at some arc footage of what you don't want to see and how to fix it. So now we're going to watch this at about 40% speed, and then I'll play it back at 100% speed so you guys can see real time what's going on. Anyways, I started to try and weld this joint here. This is just a butt weld, and you can see my arc gap is a little bit long and I'm not running enough amperage, and because of that I'm just melting the edges of the plate because the heat is not concentrated enough to actually get them to flow together. If you ever see the edges of the plate on something like this doing this, that's because one of two things: not enough amperage or too long of an arc gap. So to fix it, you can move that arc gap in closer, or you can increase the amperage. In most cases, you're probably going to have to do both of those things. Eventually, I am able to get it to join together, and that's because I increased my amperage and tightened the arc up, and probably went just a pinch slower to get it to join. Once it's joined, it's easier to maintain that line of fusion. And you can see there how tight the arc got compared to what it was, and everything looks good. Now let's watch that in real time and see what's going on. So now let's look at the arc footage of a complete weld. I'm going to tack weld both ends of these plates, and I'm leaving a little bit of a gap, not a huge gap, probably around 1 millimeter or a little bit under 1/16 of an inch. Not much, just a little bit. That will help us. Once everything's tacked up, I'm going to run the same 120 amps. I'm going to be moving fairly slow, and I'm going to be pushing filler in as I go. Now keep in mind, because of that gap, I'm going to have to push in more filler than if I'm just running a bead-on plate, because a bead-on plate, the weld will just more or less rise up. In this case, it's actually going to sink down because we have to replace that gap with actual metal. So I'm pushing about 1 millimeter, millimeter and a half, or about 1/16 or a little bit less every time I dab it. I'm pushing it in order to fill it. And I didn't even push enough filler in this because the weld was more or less flat when I was done with no reinforcement. Again, this isn't a perfect example. I should have been pushing a little bit more filler, but more on that later. So on this set of plates, I left a gap of about 1.6 mil or about 1/16 of an inch, and then added filler to help bridge the gap. When you have a gap like that, it is not possible to do a fusion weld simply because you're just going to melt the edges of both plates and they're not going to melt together. The gap is simply too much, but by adding filler, you're able to bridge the gap. Now, like everything on this channel, I tend to just make a weld and talk about it, and mistakes are very common, and this is a great example of what can happen. And what I mean by that is I'll put a picture up right now, but this, even though I was successful in bridging the gap and I happen to have penetration and a pretty decent bead on the inside, it's not perfect, but it's decent. The face of it is more or less underfilled. And this is very common when you're trying to bridge a gap that you actually underfill it. What you don't want to do in this case is run less amperage and run cold to where you have reinforcement on the face of it, but no penetration or fusion through it. And that's probably the biggest mistake I find people doing with open gaps is they reduce the amperage. They're able to make a nice looking weld that protrudes off the face so it looks like you have reinforcement, but you simply don't have any penetration or fusion, and you more or less have a bead sitting like caulk on the face of it. So you're always better off running hot enough to where you know the bead is sunk in there and has penetrated and fused something. And in the case of what we got here, going back over it with another pass to bring the reinforcement out will make a very strong weld that will likely not fail. Far better than just running a single cold pass and having no weld depth per se. Now, there are ways to achieve full fusion in one pass with the proper amount of reinforcement out the face. One of the issues I had is that limiting myself to 120 amps, if I tried to push any more filler rod into that, the molten puddle would have quenched, and then I would have had to slow down even more than I was, which would present issues. So I should have been up at 130 to 140 amps, been pushing more filler, and then I could have easily brought it out past flush on the face, plus having really good fusion on the inside. So there is an issue with amperage where if you don't run enough, you are not going to have very good success doing this. All right, well, I think I covered enough about the overview of doing butt welds. I want to give you a couple more tips and then we'll go to conclusion. All right, so I got a couple quick tips for you guys that should help you get better results in this and your welding in general with TIG. So the first one is filler rod. I kind of covered this in the previous video directly dealing with filler rod, but I'll mention it again, and that is if you're feeding filler and you notice that the rod is sticking to the plate, you may be hitting too far forward of the leading edge, or when you retract it out of the puddle, you're touching it to the plate, or you're just running too low of amperage. And it's a good indication if the filler rod's sticking, you're not running enough amperage. If you increase the amperage and the filler rod doesn't stick but you're melting through the plates, well then you probably need to go down in filler rod diameter to make that all easier for you. So you want to be mindful of running enough amperage. And again, I can't stress to you guys how important it is to move at a moderate pace with the proper heat input, because you will not achieve any kind of fusion. And you saw it in the video how bad it can be if you run too fast. You basically don't fuse anything. So your travel speed is of the utmost importance. You must go slow. TIG is a very slow process in comparison to almost every other form of welding. Do not treat it like stick. Do not treat it like MIG, especially spray arc or dual shield. Those have nothing in common with the travel speed of TIG. And speaking of filler rod, these filler rods are in alloy. They're not just the same material as the base material you're welding, and they have what's known as deoxidizers. By doing fusion welds, your ability to join material with defect-free welds becomes diminished because there is no deoxidizers that are being introduced to the molten pool. So it's always in your best interest to use filler material to join two pieces. And speaking of joining two pieces, I cannot stress the importance of having a proper fit up. TIG is one of those things that, yeah, sure, you can bridge a 1/2 inch gap with it and make it work. I mean, your weld is going to be trash, but yeah, you can, because you have that foot pedal to control heat input. So you can bridge gaps that no other process could even dream about. But the problem is that when you get to having poor fit ups like something like this, and you're trying to weld all of that straight through, guess what? Your penetration and fusion is going to be so variable that at the end, you're not really producing anything with any strength. So it is imperative that you maintain proper fit up, which proper fit up means completely tight or a slight gap. It also means beveling thicker pieces, because TIG does not have that much penetration. And if you try and weld 3/8 plate with no bevel, your depth of fusion is going to be minimal at best. It has the least amount of penetration, arguably, than all of the processes, especially if you go too fast. So it's all things to consider to get decent results, but I can't stress enough, have proper fit up. Now, another thing, and I alluded to it earlier, clean the edges of your material. A lot of what you see on some of my welds where it looks a little scaly is exactly that. I didn't prep these that good, and especially the edge, I didn't clean that to bright and shiny material. When you don't do that with TIG, all of that material winds up in your weld pool, and then it gets deposited on the surface, or worst case, inside of your weld, and that can be a detriment. It can create things like porosity, but it can also make the molten puddle flow out poorly. Now, on that topic, I can't stress enough how important it is to have proper argon shielding, aka you don't have leaks in your system, you're using 100% argon and your flow is high enough, because the molten pool will react with oxygen if you don't have proper argon coverage, and that will also make your welds look poor. Now, my welds are fairly clean, especially on this one is probably the better out of them, but even so, looking at it, it's a little bit scaly. Again, it goes back to prepping the material, having the right travel speed, the right flow. However, I can't stress enough the importance of focusing on results, not on appearance. I see so many new TIG welders so happy that they made this perfect clean stack of dimes that look really good, but they don't realize that they have no fusion and no penetration, because what they did to achieve that was run cold settings. The same things that affect MIG and stick also affect TIG. Like, people like doing stacks of dimes with MIG. Well, you try and make a perfect, nice, clean looking stack of dimes with TIG, odds are you're running too cold. And because of that, you're going to have no fusion and you're making weak welds. So I can't, again, I hate to say it, to beat a dead horse, stress enough how important it is that you do welds and then you cut them, you etch them, you break them, you look at it, because what you're seeing on the surface might not coincide with what's actually going on internally. And you do not know what's going on internally on your welds unless you test what you're doing. I can give you all the magic settings. I did all of these welds at 120 amps with filler, without, and I had completely different results in every one of them for penetration. And that is why you need to check your own work. I'm here to provide advice and tools to get you good results. You need to do the practice and you need to test to verify you are on track with where you should be. Now, with that said, let's go to conclusion. So in conclusion, what did we learn today? Well, we learned a ton to do with butt joints, and I hopefully gave you enough information to where you can work with to understand what you need to do and what you should be seeing in your results. And again, I can't stress the importance of testing your own work. You can't go by what I or anyone else says on the internet. You have to look at what you have and ask yourself, is this correct? Is this good enough? Hopefully I gave you enough to determine that. Now, the reality is butt joints like this are fairly uncommon to actually do. If you're welding pipe or some kind of structural steel, yeah, this would be far more common. But in all of the years I've been welding, it's pretty uncommon that I were to do something like this. Normally, I would have a backing plate that goes behind the two. I would have an open root and I would weld it that way. Or I would just straight open root bevel plates and then weld it out and do it that way. So this kind of, cram it tight or a slight gap and weld it, honestly, you won't be doing too much of that in the real world. However, this is a great way to practice your skills to get good results. And that's the thing. You want to do this economically. I get it. A lot of you guys don't have big budgets, and you already spent $1,000+ on your welding machine, plus a tank, argon, plus filler. It costs a lot of money to get in a TIG. If you want to do this economically, start out with this and go from there. And it doesn't hurt if you got a couple plates, you know what, cut them in half and then re-weld them together. Like this, I could get at least 2-3 more welds on this simply by cutting it in half and then re-welding it. So you can make economical use of what you have and get a ton of practice out of not a lot of material. Not to mention, you could also come back here and run beads on plate across it to get more practice adding filler, because getting good at TIG is all about practice and mastering the basics. With that said, if you got any comments or questions on this, feel free to leave them. Otherwise, until next time.